Okay, so in this video, we're going to take a look at sort of the most simple way to have our LabVIEW talking with Arduino and recording that data into a waveform chart. And so the way we get that accomplished is we use a flat sequence. So that sort of looks like a film strip here in your block diagram. And what a flat sequence does is it tells our LabVIEW code, since LabVIEW will execute whatever code is available to be executed wherever it is in our block diagram. A flat sequence tells LabVIEW, I want you to step through this sequence in this order and don't do anything in a different order. We do that because we want to make sure that LabVIEW takes a second to chill before it tries to initiate some communication with the serial buffer. So what we're going to do first is we're going to initiate and configure our serial port resource. So we're just going to tell it what COM port we want the serial communication to happen at, and we want it to and tell it what baud rate it should be happening at. And so if you double click on that Visa serial, you can see that there's a whole bunch of different things we can select as we go through. We won't be getting into these quite so heavily right now. If you're experiencing issues, this might be one place to start. I know some folks didn't have, they had trouble with whether there was a termination character at the end of their serial buffer to let it know it was the end of a message. And so that could be one issue. If your Arduino code runs fine in your serial monitor, and you're sure that your LabVIEW code is developed properly, but they're not talking to each other, that's one place to look. So then after we configure that serial port, we're telling LabVIEW to wait a second and a half, and then to enter this while loop. And our while loop says, execute the code inside here until we click the stop button. And at each point in the loop, we're going to have a look at the serial port, and we're going to say, hey, did any bytes come in? Is the number of bytes that came in greater than 0? If that's true, I want you to read those bytes that came in. And in my case, I wanted to look at that raw input, so I put an indicator here called read buffer. And then I want to take that output string, parse it into a group of an array of doubles, and then I want to pass that pair of doubles into a waveform chart. And so what that looks like on your front panel, you can see over here. And one thing that a lot of people ran into, let me just stop this, is if you right-click on when you're not running, and you right-click on your waveform chart, let me just do it up here so you can see the full menu. You can click Properties, and when you go into Plots, let me see, in Appearance, you'll see the number of plots shown. Some folks had that just as 1, so it was passing both numbers, the temperature and the humidity, to the chart, but the chart was only charting one of those values. So you want to make sure that that's 2. And then you can go in here, and by default you'll get plot 0 and plot 1. You can rename those. So plot 1, let's see, outputting temperature in, I think plot 1 for me is temperature. That would make sense here for this room I'm in, about 60 degrees. Maybe not, or maybe my readings are just weird. But in either case, call 1 temperature, 1 humidity. it's looking to me like the second number is temperature because it's coming in as 77.00 here in our read buffer. So we probably have these flipped. So then this thing's going to loop and loop and loop until I click stop. And then when I click stop, we're going to execute the next frame in the flat sequence. And that's to close the serial port and reopen it for another program to look at it. You'll note you cannot open the serial monitor in Arduino while this code is running. Only one program can have access to that read-write buffer at a time. And so we go into our Arduino code, and by the way, both this VI and the Arduino code are available in brightspace. And so we can look through our code. I know a lot of you have already seen this, but we're including our DHT library. We're creating a DHT object from that library so that we can use its methods. We are instantiating some integers that one we're calling check, one we're calling temp C, and one we're calling relative humidity. We're initializing, in our setup, we are calling our serial.begin. We see that that's at our 9600 baud rate. Then we're going to have a quick delay just to let everything configure. We're calling a float here of temperature for our Fahrenheit calculation. And then we're going to use the DHT.read and DHT.humidity methods to pull out the temperature in Celsius and the relative humidity. Then we're going to call temp F by multiplying our temp C by 1.8 plus 32. Then we're going to serial print RH, serial print a comma, and then serial print LN, which is going to end our line and go to the next one, TMPF. So serial print LN will print the new line character at the end of temp F, so that the next serial print statement goes to the next line. And then we're going to delay 1.5 seconds. Why? Because that's a limitation of the DHT11. So if you query faster than that, you can get like -999 or some other weird number that doesn't make any sense. So that's our two pieces to getting our DHT11 to talk to Arduino and then talk to LabVIEW. And so additionally, you'll notice like this is in our loop, right? So when the Arduino is on, this thing is just printing RH and temp all the time, just over and over and over and over and over again. We may not want it to do that. We may want other things to come in and out of the serial port depending on what we ask it for. So at some point, we're going to have to change this code so that it doesn't rely on 1500 milliseconds between checks, because we might have data that we need to read more at a higher frequency than that, and we don't want to be stuck on whatever the DHT says. Let's say you had a photodiode or a photoresistor or a thermistor that you want to read more frequently. And you may only want certain data at certain times, so we want to be able to write to the serial buffer and then have Arduino read that and say, oh, okay, you want this temperature, you want this humidity, you want this voltage, here it is. And so in my next video, which will come up in a little while, probably maybe next week, we'll take a look at how we can do that actual handshake back and forth between LabVIEW and Arduino. So as one closing thing, so we've stopped that. So we're going to go look, I'm going to show you the serial monitor. This is what LabVIEW actually sees when it starts up. So this is what's coming in, and then this string is what's getting pushed out into the two numbers that are seeing our waveform chart. So you don't need LabVIEW. I hope most of you have realized this. You don't need LabVIEW to monitor what Arduino is actually printing to the serial port. And if you want to simulate later on some of the inputs that might come from LabVIEW to make sure your Arduino code is processing them properly, you could type them into this command line and press send. So you could, have a command that says give me temp, and then the Arduino would say, okay, oh, you want me to give you temp? Here's temp. So that's what we've got so far. More videos to come. Thank you.